In section 3 of chapter 14, we discuss another type of three-dimensional figure called a pyramid. We've probably seen these before, but a pyramid in geometry is a three-dimensional closed figure where all vertices of a polygon connect to a non-planar point. So that non-planar point we call the apex. So this is the apex, and then the polygon that forms the I don't want to say the base, but is at the very bottom, or is that I should say that is opposite the apex, is called the base. Okay, so this polygon here is called the base, and then all the other sides of the pyramid we just refer to as sides. And when we name a polygon, we always name it after the base. So if the base is a square, such as this one, at least I'm assuming it's a square, we would call this a square pyramid. Okay, and then we also talk about two other very important things in a pyramid. So the height is actually the distance from the apex to the centroid of the base. So if this is the centroid, which would be the middle of that polygon, this should be the vertical distance. It's not too vertical right now. Let's try that again. Third time's a charm, right? And okay, well, you get the point. But anyway, this is the height of the pyramid. Okay, so that's one height, and then we also talk about this line on the pyramid that is labeled as S, and that is the slant height. Okay, and the formulas that the book uses slant height is typically referred to using an L. So they have it labeled as S in this diagram, but we're going to be using an L for that value, and that is just the kind of the distance the distance from the apex to the midpoint of the side of the base. Alright, and then as we talked about in the last video, or one of the previous videos with prisms, we can talk about different numerical quantities associated to any three-dimensional figure. Volume is one quantity, lateral area, and surface area. So again, lateral area is just the area of the sides, and then surface area includes the lateral area, but also includes the area of that base. So the volume of a pyramid is given by 1/3 area of the base times its height, and then lateral area is, this formula may look complicated, but essentially what it's telling me is, okay, find the area of each side. Each side is a triangle. Okay, so I find the area of this triangle. Again, this would be the side length, this would be the height of that triangle, L. And so I'd have to do, for this triangle, I'd have to do 1/2 times side times the slant height divided by 2. Or sorry, I think I said that already. But slant height times side of a triangle divided by 2. And then however many sides I have for the base, I'd have to multiply that by this quantity to determine lateral area. Surface area is then the same thing plus the area of the base. Alright, and we're actually going to jump right into into examples in this video. And so if I start with a regular pyramid with a square base, so I'm going to make a little diagram here. So here's my square base, and here's my apex, and so I connect this, I connect my apex to each side. Okay, let's try that again. I'm just going to use my tool. So I connect my apex to this point, apex to this point, apex to this point, and down here as well. Okay, So now I have a square base. I know each edge has side length 6, and the height, again, that would be from the apex to the centroid, meets at a right angle. This has a length of 4 units. Okay, so it says, what is the ratio of the number of cubic inches to the volume to the surface area? Great. So what I'm going to do is I'm actually going to kind of flatten this again into 2 dimensions. So if I look at, here's the height, I need to know 2 things. So what I need to do is I need to determine slant height, and then whatever this value is, which is going to be, if this meets in the centroid, that's this distance here. So this distance x is this distance x here. So that should be half of 6, so this should just be 3. Right angle, this is 4. And I want to determine the slant height L here, so I can use the Pythagorean theorem or recognize this as a Pythagorean triple, so L is actually going to equal 5. So now, according to this problem, they want the ratio of volume to surface area. So actually, let's go ahead and compute this. So volume is going to be 1/3 times the base, times the area of the base times the height. 1/3 area of the base is side squared, so that's 6 squared, times the height is 4. And so this is going to be 48 when I do the computation, so 48 inches cubed. And surface area is going to be area of the base plus the number of sides times the side length times slant height over 2. So area of the base, that's going to be 36, plus n here is 4, side length is 6, times slant height, which we said was 5, all of this over 2, and doing this out, I got 96 inches squared. Okay, so if I'm looking at volume to surface area, that is going to be 48 to 96, or a 1:2 ratio. Okay, which answers the problem. Example 2. We're going to talk about a triangular pyramid, which we call a tetrahedron, and specifically we're going to talk about a regular tetrahedron, which is when all edge lengths are the same. So it's composed of 4 equilateral triangles. So we want to find the formula for the surface area and volume for a regular tetrahedron. So surface area, I think, is the easier place to start at. So if we know it's composed of 4 equilateral triangles, if it has a side length of s on each side, or if each side has side length s, and then this side back here would be s as well, it would be 4 times, and then we discussed the area for an equilateral triangle is s square root of 3 over 4, so s is a side length, and so surface area here is just going to be s square root 3. Okay, that one was relatively painless. Now, volume gets to be a little bit more interesting, because to compute volume, I need to determine the height. So here is the height, meets at a right angle. Here's height. Here's my centroid. And now, to properly compute this, I need to remember that, okay, if I look at this centroid, the centroid splits the median, so it splits the medians in a 1:2 ratio. Okay, now remember that the centroid of an equilateral triangle is the intersection of the medians, is the intersection of the altitudes, intersection of pretty much everything, the intersection of the angle bisectors, all that good stuff. So in this case, it would make 2 congruent segments. This would be a right angle as well. But if I call this x, so I'm going to call this distance here x, and then so I'm looking at this distance here from the midpoint to the centroid up to the apex, and then from the apex down to this midpoint. Let me put that in purple. Okay, this distance would be the height of the equilateral triangle, which I can determine that using our past knowledge as s square root 3 over 2. Okay, again, because this over here would be s over 2. Alright, and then with this I can, and remembering the fact that this splits the median splits the medians are split by the centroid in a 1:2 ratio, and this would also be that height of s square root 3 over 2, the entire length here. So I would need to take 1/3 of that for x. So what I'm saying is that x is equal to 1/3 of s square root 3 over 2, which is s square root 3 over 6. Okay. Now the whole goal here is to determine the height, because in the volume formula I can find the area of the base. That's fine, we got that already, but it would be 1/3 area of the base times height. I need to find the height. So to do that, I'm going to set up the Pythagorean theorem. So I have s square root 3 over 2 squared is equal to s square root 3 over 6 squared plus h squared. Okay, and after you simplify this, you get 3s over 4 is equal to 3s over 36 plus h squared. Okay, and then simplifying this down, you get 24 over 36s is equal to h squared. Sorry, this would be s squared. Okay, and then finally, this would give you that height is equal to square root of 2 over the square root of 3s. And then finally, we're ready to do volume. And so volume is going to equal 1/3 of the area of the side. Okay, and then so that is going to be s squared times square root of 3 over 4. And then I have to multiply this times the height that I just found. So s square root 2 over square root 3. And this, when all is said and done, simplifies down to s cubed square root 2 all over 12.